Hi, today we're going to be learning how to find the volume and surface area of prisms. First, I want to remind you about what prisms are. A prism is a 3D object that has the same shape on both ends, which is the base shape. So over here, I've got an example of a triangular prism where I've got a triangle on the front and a triangle on the back over there. They are opposite. They're the two ends of the prism, and the two triangles are exactly the same as each other. A prism also has a constant cross section. That means that if I take this prism and I cut it somewhere in the middle, I'm going to end up with the same shape as I started with on the two ends. So over here, this triangle that I end up with is going to be the same as this triangle and the one that I had at the other opposite end over there. Okay, here are a few examples of different kinds of prisms. Here's a rectangular prism or a cuboid. A rectangular prism or a cuboid has rectangles on opposite ends. You can also see that over here, the top and the bottom are also the same rectangles as each other, and the two sides over here are also the same rectangles as each other. In a rectangular prism, all three pairs of opposite sides will be rectangles the same as each other, and you could actually use any of the three pairs of opposite sides as your base. Then we have a cube. A cube is a special kind of prism where all of the sides are the same as each other. So if we look over here, the front is a square, the back is a square, but you can also see that all of the sides around it as well, which we call the lateral faces, are also the same squares as the front and the back. Okay, so that's a cube. Then we have an example here. We've got a triangular prism. In a triangular prism, you'll have a triangle on the two ends, and they will be the same as each other again. So here I've got a triangle, and then the same triangle on the opposite end over there. So these are just a few examples of prisms. You get lots of other different kinds of prisms as well. You get hexagonal prisms and pentagonal prisms and octagonal prisms. The name of the prism is normally based on the shape of the ends, the base shape of your prism. So like over here, with a triangular prism, the base shape is going to be triangles, so that we call it a triangular prism. Rectangular prisms have a special name. You can call it rectangular prisms, you can also call it cuboid, and then the cube has a special name all by itself as well. But most of the time, we name it based on the base shape of the prism. Okay, now looking at the base and height of a prism. The base is the two faces that are opposite each other, which are the same as each other. So like in this one over here, the two triangles are going to be my base shapes. Then the height of the prism is the distance between the two bases, between the two ends. So that's the height of the prism. Okay, now let's have a look at nets. A net is what you get when you unfold a prism. Our first prism over here is a rectangular prism, also called a cuboid. If I take this prism and I unfold it, I'm going to end up with something that looks like this. So over here, I've got my two ends at the top and the bottom over here. And then these faces are what I would get if I were to unfold this and open it all out. These are what we call the lateral faces. They're the ones that go around the sides, where these over here are the two ends. Okay, so that's what a net will look like for a rectangular prism. Then we have a cube. For a cube, we've got a net that looks like this, where I've got my two squares at the top and the bottom, which are the front and the back, or the two ends. And then I've got the squares that go all the way around. Remember, a cube is special because all of the faces are the same as each other. So they're all going to be the same square as each other. Okay? Then we have a triangular prism. The net for a triangular prism is going to look like this, where I've got my two triangles, which are the top and the bottom. They're the two ends. And then the lateral faces, which are the ones that go around the sides, are going to be like this. When I unfold it, it's going to look something like that. Okay, so those are what our nets are going to look like for prisms. You'll have on the two ends will be your base shape, and then you'll have rectangles that make up all the faces that go around the prism, and that forms this rectangle over here. Okay, now we're going to go on to surface area. To find the surface area of a prism, we use this formula. Surface area is equal to 2 times the area of the base plus the perimeter of the base times the height. So let's have a look at where this formula comes from. Okay, so first of all, if we look at this as an example over here, remember the base is the two ends of the prism which are the same shape. Okay, so whatever that shape is, that's what you're going to be using when you're working with the area and the perimeter of the base when you're working out the surface area. So over here, if I look at my net, this part of the formula, 2 times the area of the base, is going to come from these two faces over here. So it's 2 because there are 2 of them. So I work out the area of the base, which in this case is a triangle, and I multiply it by 2 because the 2 on the 2 ends are identical to each other. So I work it out once and I times it by 2. Then this part over here is for this rectangle in the middle, which is the rectangle that I get when I unfold my prism, and it comes from the lateral faces. So when you unfold the prism, you're going to end up with a rectangle between the two base shapes like this. For the rectangle, the length of the rectangle is the same as the perimeter of your base shape. Remember, before you unfolded it, this lay against that side over there, and this lay against that side over there. So this whole length over here is the same as the perimeter of the base. So to work out the area of this rectangle, our length is the perimeter of the base shape, and the height is the distance between the two bases over there. That's that distance over there. Okay, so over here, that's the rectangle that I'm working with, where this length over here is the perimeter of the base, and the height over here is the same as the height of the prism. That's the distance between the two ends of the prism. Okay, so that's how you work out the surface area of a prism. You take the area of the base and you multiply it by 2, and then to work out the area of the rectangle that you get when you open it all up, you take the perimeter of the base, which is this distance over here, and when you open it up it's that distance, and you multiply it by the height of the prism, which is the distance between the two ends. Okay, when we work out surface area, it is measured in units squared, so it could be millimeters squared or centimeters squared or meters squared, etc., because it is area. Okay, now let's go on to the volume of prisms. The volume of a prism is the amount of space that is occupied by the 3D object. It is measured in millimeters cubed, centimeters cubed, meters cubed, etc. And we use the formula volume equals area of base times height, where again the base is the base shape of the prism, which is the shape that's the same on the two ends. So you're going to work out in this one over here the area of the triangle, or if it's a rectangular prism, you'd work out the area of a rectangle. If it's a square prism, you'd work out the area of a square, and so on. And so that's going to give you the area of the base over there. And then you multiply it by the distance between the two ends, which is your height, like that. Okay, then we've got the capacity. Now the capacity is different. It's similar to the volume, but it's slightly different. The volume is the space that the object itself takes up. The capacity is the space inside a hollow 3D object that can be filled. So it is the maximum amount that a container can hold. And capacity is measured in milliliters, liters, kiloliters, etc. Okay, now let's go and have a look at the conversions that you need to know. First, if you're converting between centimeters and millimeters for normal length, you multiply by 10. If you want to convert between centimeters and millimeters for area, then it's centimeters squared to millimeters squared, so we multiply by 10 squared, which is 100. If you want to convert between centimeters and millimeters for volume, so it's cubed, then you multiply by 10 cubed. So anytime you're going from centimeters to millimeters, you're multiplying by 10, but if it's for area, it's 10 squared, and if it's for volume, it's 10 cubed. If we're converting between meters and centimeters, we multiply by 100. Okay, so for normal length, you just multiply by 100. But if it's area, just like we were doing for this one over here, if we're multiplying by 100 for normal length, then for area, we're going to multiply by 100 squared. And for volume, we're going to multiply by 100 cubed. And then for meters to millimeters, we multiply by 1,000. So we use the same concept. When we're working with area, we multiply by 1,000 squared, and when we're working with volume, we multiply by 1,000 cubed. So whenever you're working with normal length, you just use the normal conversion. So 1 centimeter is 10 millimeters. 1 meter is 100 centimeters. 1 meter is 1,000 millimeters. When you're working with area, which is the unit squared, you take that same conversion factor and you multiply by that squared. When you're working with volume, which is the unit cubed, you take that same conversion factor and you multiply by that conversion factor cubed. Then you also need to know how to convert between volume and capacity. So for volume and capacity, the easiest ones are centimeters cubed to milliliters. They are a direct conversion. So 1 centimeter cubed is the same as 1 milliliter. And meters cubed is the same as kiloliters. If you have got your volume in millimeters cubed, you're going to have to convert it first to centimeters cubed and then convert it to milliliters. So you just need to make sure that you can get your volume to centimeters cubed or meters cubed, and then you can just convert it to capacity. Right, let's go and have a look at our first example for today. In this example, we need to calculate the volume, capacity, and surface area of this box. In the box, we've got a distance over here of 5 meters. This distance is 12 meters, and this height over here is 15 meters. Let's go and have a look at how we would find the volume, capacity, and surface area of this box. Okay, so the first thing we're going to do is find the volume. So to find the volume, I use the formula area of base times height. Okay, now in this case over here, this is a rectangular prism, so the base is a rectangle. So the formula for the area of a rectangle is length times breadth. So I can say this is length times breadth times height. So you can go straight to that formula when you're working with a rectangular prism. Length times breadth times height. Okay, so now I'm going to go and find the volume by filling in the values. Now I can choose which rectangles I want to be my base, because with a rectangular prism you can choose any of the 3 opposite ends or sides to use as your base. So if I choose to make the front one over here my base, so that's 5 by 15, then my height is going to be 12. Okay, but it doesn't matter because we're just multiplying them all together anyway, so it doesn't matter what order we multiply them, I'm still going to get the same result. Okay, so if I say that the length of this, if I'm choosing to make this my base over here, the front, then the length is going to be 15 times the breadth, which is 5, times the height, which is the distance between the 2 ends. So if I'm choosing to make the front one of my bases and the back the other base, the distance between those 2 ends is 12. So that's going to be 12 over here. So I'm multiplying all 3 of them together. 15 times 5 times 12. Okay, so let's go and work that out. And that gives us 900 meters, and volume is measured in meters cubed. Okay, so that's what you would get for the volume for that one. Now we have to go and work out what the capacity is. Okay, so for the capacity, I have to check if my volume is in one of the 2 units of measurement that I can just convert directly to capacity. In this case, meters cubed I can convert directly to capacity because meters cubed is the same as kiloliters. So over here, if it's 900 meters cubed, that means that it's the same as 900 kiloliters. So I didn't have to do any conversion first to a different unit of measurement for the volume. I could go straight to the capacity. Okay, now let's go and work out our surface area. So to work out the surface area, we're going to take 2 times the area of the base plus the perimeter of the base times the height. Okay, now this is not the only way of doing it. You can work out all of the faces and just add them up. So that's another way of doing it. This method is useful for when you are starting to do prisms that have irregular faces as your two bases, but you don't have to do it this way. You can also just work out the area of all the faces and add them up. Okay, but I'm going to do it this way so you can just kind of get used to it. Right, so 2 times the area of the base. So the area of the base again is a rectangle, so it's length times breadth, plus the perimeter of the base is 2 lengths plus 2 breadths. Now, because there's more than one term in that over there, I put it in brackets. If it was just one term, so if there was no addition, no subtraction, nothing, I wouldn't need to put it in brackets. But because there is addition, I have to put that in brackets. And then I multiply that by the height of the prism. Okay, so now we're going to go and fill in our value. So I've got 2 times the length times the breadth. Again, I'm going to use the front of my prism as my base shape. So it's going to be 2 times 15 times 5 plus, now I have to keep it consistent. I can't change which shape I'm using as my base now. I have to stay with the same shape for my base. So I'm still working with that front as my base shape. So it's going to be 2 times the length, which is 15, plus 2 times the breadth, which is 5. And then I multiply by the height of the prism, which is the distance between the two ends. So that's going to be 12. Okay, so now we can go and work that out. So I've got 2 times 15 times 5, that's 150. Plus, in brackets here, 2 times 15 is 30. Plus 2 times 5 is 10 times 12. So that's 40 times 12. That's 150 plus 480. And that gives me 630 meters squared. So that's what you should get for that question. Right, now we're going to go on to a few that you're going to do for yourself to practice this. Here's the first one you're going to do. Just like in the example I just did with you, you need to find the volume, the capacity, and the surface area for this box. I'm going to give you 2 minutes to do this question. Okay, so let's go through that and see what you should have got. Right, so here I've got the prism that we were given. In this case, they've told me that this side over here is 5 millimeters. They haven't given me any other dimensions, but that's fine because they told me that all 3 of these over here are equal to each other, which means that this is a cube. Okay, so to work out the volume of our cube, again, it's area of base times height. Now the base is a square, so that's going to be side squared times the height. Another way of writing this could actually just be side cubed, because the height is the same as the dimensions of the square. So you can just do side cubed. So it doesn't matter how you write it. No matter what you write, you're going to end up multiplying 5 by itself 3 times. Okay, so over here, I've got 5 cubed, or 5 squared times 5, or 5 times 5 times 5, as long as you are multiplying 5 together 3 times. So over here, that gives me 125 millimeters cubed. Okay, now we have to find the capacity. To find the capacity, my volume needs to be in centimeters cubed or in meters cubed. Now in this case, it is not in centimeters cubed or in meters cubed. To convert from millimeters to centimeters, I'm not going to go to meters because it's further away. It's easier to convert from millimeters to centimeters. So to convert from millimeters to centimeters, I need to divide by 10. Okay, so my capacity, I'm going to to work on my capacity, I first need to convert the volume to centimeters cubed. But so what we're going to do is we're going to divide by 10 to convert from millimeters to centimeters. But because we're working with volume, I'm going to divide by 10 cubed. Okay, so 125 divided by 10 cubed is 0,125 centimeters cubed. So this is what I've done over here. I divided by 10 cubed to get from that to that. So now I can write down what my capacity is, because it's now in centimeters cubed, so I can convert that directly to milliliters. So my capacity is going to be 0,125 milliliters. Okay, now let's go and work out our surface area. To work out the surface area, I have a couple of choices. Remember I said you can just work out the area of all the sides and add them up. Now that in this case is actually going to be the quicker option. Because this is a cube, all of the sides are identical to each other. There are 6 of them all together, so I can just say 6 times side squared, because it's a square. So the formula for the area of a square is side squared. So this is one way of doing it. So 6 times the dimension over there is 5, so it's going to be 5 squared. So that's 6 times 25, which gives us 150 millimeters squared. Okay, so that's one way of doing it. Remember I said when you're working out the surface area, you can work it out by just working out the area of all the faces and adding them up. So that's what I'm doing over here. I'm working out the area of one of the squares and saying because there are 6 of them, I'm just going to multiply it by 6. So that's one option. So I can also work out the surface area using the normal formula, which is surface area equals 2 times the area of the base plus the perimeter of the base times the height of the prism. So now because this is a cube, the base is a square. So it's going to be 2 times the area of a square, which is side squared, plus the perimeter of the base. Again, the perimeter of a square is 4s times the height of the prism. Okay, so now if I go and fill in my values, it's going to be 2 times 5 squared plus 4 times 5 times the height, which is the distance between the two ends. It's also 5. So over here I've got 2 times 25 plus 4 times 5 times 5 is 100. So that's going to be 50 plus 100, and that gives me 150 millimeters squared. So that's the same result that I got with the other method, but using the formula that we can use for all prisms. Now obviously the other method was much quicker, so the method that you use will depend on the prism that you're working with. In this case, this is not the quicker option. The quicker option is just to work out the area of one side, which is a square, and multiply it by 6. Okay, right, let's go on to question B. Here, once again, you have to work out the volume, capacity, and surface area of this box. I'm going to give you 2 minutes to do this question. Okay, so let's go through that question and see what you should have got. Okay, so over here I started off by writing my formula. So the formula for the volume is area of base times height. Now in this case, I'm working with a rectangular prism, or this could actually be a square prism as well. If you look over here, I've got 8 and 8. So that means that this top over here is a square and the bottom is a square. It's an 8 by 8 square. So you can work with it as a rectangular prism where you're working with the rectangle over here as your base, or you can work with it as a square prism if you're working with the bottom and the top as your base. Okay, so it's entirely up to you. In this case, I'm going to choose to do it as a square because I have the 8 and the 8 making a square over there. So it's side squared to work out the area of a square, but you could also have had length times breadth, and either way is fine, multiplied by the height. Okay, so now over here I've got 8 squared times the height, which is 2. So that's 64 times 2. That gives me 128 centimeters cubed. Okay, so now that's my volume. The capacity I can do straight away because the volume is in centimeters cubed. I can convert it directly to capacity. The capacity is equal to 128 milliliters because there's a direct conversion between centimeters cubed and milliliters. They're the same. Okay, so now that is how I work out my volume. Now let's go and have a look at the surface area. So the surface area for this, again, there's more than one way that you can do this. You can do it using the formula that I've got over here, 2 times the area of a base plus the perimeter of the base times height. Or you can just work out the area of the different sides and add them together. So I will do both. You can choose which way you want to do it. I'm going to start off by doing this method this time. So if I'm choosing again to have the square, the 8 by 8 square as my base, then it's going to be 2 times side squared plus 4 times the length of the side times the height of the prism. So that's going to be 2 times 8 squared plus 4 times 8 times the height of the prism, which is 2. Okay, so that's going to be 2 times 64 plus 4 times 8 times 2 is going to be 64. That's 128 plus 64, which gives me 128 192 centimeters squared. So that's one way of doing it. The other way of doing it is to take the rectangles that make up the sides and work them out and add them up. So I can say over here I've got 2 by 8. This is also 2 by 8 and 2 by 8 and 2 by 8. So I've got 4 rectangles that are the same as each other. So 4 times length times breadth for those rectangles, plus over here I've got a square at the bottom and a square at the top. So there are 2 of those. So 2 times side squared. So this is going to be 4 times 2 times 8 plus 2 times 8 squared, which gives me 64 plus, sorry, this is supposed to be 2. 2 times 8 squared, which is 64, which gives me 192 centimeters squared. So either way, you're going to get the same result. So this method, I was using that formula, okay? This method, I just took the different rectangles that made up the sides around my prism. I worked out the area of each rectangle, and when there are ones that are the same, I can just multiply by how many of those there are. So that's what I did over here. There are 4 of these rectangles that are the same. It's 2 by 8, 2 by 8, 2 by 8, and 2 by 8. Those are all the same. So I can just work it out once and multiply by 4. And then I work out the area of the squares, which are the top and the bottom. Again, they're the same. So I can just work it out once and multiply it by 2. Okay, so that's what you get for that one over there. Right, let's go to question C. Okay, so for question C, again, you need to find the volume, the capacity, and the surface area. I'm going to give you 3 minutes to do this question. Okay, so let's go through that question and see what you should have got. Right, so for this question, the first thing that you had to do before you could work out volume or surface area or anything is you have to first work out the length of AC over here, because I can't work out the area of this triangle, which I need to do for both the volume and the surface area, if I don't know this length over here, because it's going to be either the base or the height of that triangle. So I have to work out the length of AC. Okay, so I'm going to use the Pythagorean theorem to do that. So I've got AC squared is equal to the hypotenuse squared, that's AB squared, minus BC squared. And the reason I can do that is because of the Pythagorean theorem. Okay, so now we're going to go and fill in our values. So over here I've got 15 squared minus 12 squared, and that gives me 81. So that means that AC is equal to 9 meters. Okay, so this over here is 9. Right, now that I know that, I can use it to help me to work out my volume and my surface area. Okay, so my volume is area of base times height. So now, in this case, the base of my prism is a triangle, so the area of the base is half base times height. Now be careful over here. This h, the small h, is the height of the triangle, and the capital H is the height of the prism. Okay, they're different to each other. Right, so over here, I've got half, and then the base and height. Remember, when you're working with a right angle triangle, then the two right angle sides are going to be your base and height when you're trying to work out the area. So it's going to be the 9 and the 12. They will be my base and height. Doesn't matter which way around I do it, as long as I'm using the 9 and the 12. Okay, so it's going to be half times 9 times 12 multiplied by the height of the prism, which is the distance between the two ends, so that's 10. Okay, so that gives me half times 9 times 12 times 10 is 90. Okay, so my volume is going to be 90 meters cubed. Now, next I have to work out my capacity. Now, because it's in meters cubed, I can just convert it directly to kiloliters. So my capacity is going to be 90 kiloliters. Now we're going to go and work out our surface area. Now remember, the formula for the surface area is going to be 2 times the area of the base plus the perimeter of the base times the height of the prism. Okay, so now again, the base has to be the triangles that are the same on the two ends. So it's going to be 2 times half base times height plus the perimeter of a triangle. The perimeter of a triangle is side 1 plus side 2 plus side 3. And because I have addition, I need to put that in brackets. So side 1 plus side 2 plus side 3 multiplied by the height of the prism. Okay, now over here, before I do this, the half and the 2, when I multiply them together, they cancel each other out. So I don't have to worry about that. I'm just going to be doing my base and my height. So 9 times 12 plus, in brackets, I've got the 3 sides of my triangle. So 9 plus 15 plus 12. And I multiply all of that by the height of the prism, which is the distance between the two ends. So that's 10. Okay, so 9 times 12 is 108. Plus 9 plus 15 plus 12 is 36 times 10. So that's 108 plus 360, which gives me 468 meters squared. So that's what we should have got for question C. Right, let's go on to question D. Okay, here once again you need to work out the volume, capacity, and surface area of this box. I'm going to give you 3 minutes for this question. Okay, so let's go through that question and see what you should have got. Right, so first of all over here, I need to find the lengths of all the missing little lines that I've got over here, just to make it easier. I don't need to use anything like Pythagoras to do this. I can just write down the lengths by using subtraction and stuff. So over here, first of all, if this is 6, then that means that this is also 6. Now I'm just wanting to have the lengths of all the sides of the front face over here, because it's going to make it easier for me when I'm going to be working out the area of this, because this is going to be my base shape. Okay, so if this over here is 8, and they told me that this is 2, which means that this over here is 2, then this is going to be 8 minus 2, which is 6. And if this is 10, and that's 6, then that means that this must be 10 minus 6, which is 4. Okay, so I've got all the lengths of my sides over here that I'm going to be using when I'm going to be working out my perimeter of the base and the area of the base. Okay, so now to work out the area of the base, what I'm going to do is I'm going to take this base and divide it up into 2 pieces. There are different ways of doing this. You could divide it up into this big rectangle and that small rectangle over there, or you could do this over here and that over there, or you could even do the whole big rectangle and subtract this piece that's been cut out. So there's more than one option for how to work out the area of the base. So we're not going to be writing like we did for the previous ones. We wrote down the formula for the area of the base. We're not going to do that. We're just going to go straight into working out the area of the base using whatever method you chose to use. So over here, if I choose to divide this up like this, so I've got this rectangle and that rectangle, then for the area of the base, I'm going to have, I must put this in brackets because I'm adding 2 pieces together. So I have to put it in brackets because otherwise I'll only multiply part of it by the height, and I must multiply the whole thing by the height. Okay, so the area of the base is going to be, this over here is 6 times 6, so it's actually a square over there. So 6 times 6, or 6 squared, plus this rectangle over here is going to be 2 times 10. So that gives me the area of that whole base shape. And then I multiply that by the height of the prism, which is the distance between the 2 ends. So that's going to be the 5 over there. Okay, so that gives me 36 plus 20 times 5. So that's 56 times 5, which gives me 280 centimeters cubed. Okay, so that's the volume. The capacity, because it's already in centimeters cubed, I can just convert directly to milliliters. So my capacity is equal to 280 milliliters. Okay, so that's what we should have got for the volume and the capacity. Now let's go on to our surface area. Okay, so for the surface area, again, I've got 2 times the area of the base plus the perimeter of the base times the height. Okay, so now the area of the base is exactly what I did over here. I'm not going to do anything differently to what I did over there. Okay, so 2 times 6 times 6 plus 2 times 10 plus the perimeter of the base is now just all of the sides added up. So I've got in brackets 10 plus 2 plus 4 plus 6 plus 6 plus 8. And then once I've done all of the sides, I can close that bracket and I can multiply by the height of the prism, which is 5, the distance between the 2 ends. Okay, so now we can go and work that out. So I've got 2 times 36 plus 20 plus, this all works out to 36 times 5. Okay, so that gives me 2 times 56 plus 36 times 5 is 180. So that's 112 plus 180, which gives me a total of 292 centimeters squared. So that's what you should have got for question D, that the volume should have worked out to 280 centimeters cubed, which means the capacity is 280 milliliters, And your surface area should have worked out to 292 centimeters squared. Right, let's go on to the last one for today, which is question E. Okay, I'm going to give you 5 minutes to work out the volume, capacity, and surface area of this box. Okay, so let's go through that question and see what you should have got. Right, so in this question, the first thing I'm going to do is write down the lengths of all the sides that I already know based on what they've given me over here. So they've told me that this is 16 over here. Then they tell me over here that this, which is going to be also 16, is divided in half to give me AB and BC. So that means that if these two are equal to each other, they must each be 8. So AB must be 8 and BC must be 8. Okay, that's going to be important for me because I'm going to have to work out the height of this triangle, which is BD, and in order to do that, I'm going to have to use the Pythagorean theorem in one of these two triangles, either ABD or BCD. Doesn't really matter which one I do because they're identical, but I'm going to have to work out the length of BD because I need to know the height of that triangle to work out the area of the triangle. Okay, so those are 8, but also I need to know that because they tell me that this is equal to that. So if this is 8, it means that this is also 8 over here, and this side is also 8 over here, and this is 8 over there. Then over here they tell me that this is 10, which means that this is 10 because they told me that it's equal, and this is also 10. So now, to work out my volume, I need to work out the area of the base. So the base is made up of a rectangle, which is length times breadth, plus a triangle, which is half base times the perpendicular height. But I don't know the perpendicular height yet. I need to go and work that out using the Pythagorean theorem. So that's the first thing I'm going to do for my actual calculations now, is I need to work out the length of BD, which is the height of that triangle. So BD squared is equal to, if I work with this triangle over here, the hypotenuse is 10. So it's going to be AD squared minus AB squared, which is going to be 10 squared. That's because of the Pythagorean theorem. So that's going to be 10 squared minus 8 squared. That gives me 36. So that means that BD is equal to 6 meters. Okay, so now that I know the length of BD, I can go and fill that in over here. So my height of this triangle is going to be 6. Okay, now let's go and work out our volume. So the volume is area of the base times the height. So now, once again, this is an irregular shape. So I'm not going to write down the formula to work out the area of the base because it's not regular, but I can go straight into working out the area of the base using the formula that I have for each of the pieces of that base. So the first piece is my rectangle over here. So that's going to be length times breadth. So it's going to be 16 times 8 plus my triangle is half base times height. So it's half times the base of the triangle is 16, the whole length across there. So I'm working out the area of this whole triangle over here. So the base is 16 times the height of that triangle is 6. That's the BD that I just worked out over there. And then I multiply that by the height of the prism, which is the distance between the two ends. So that's 10. Okay, so 16 times 8, that gives us 128, plus half times 16 times 6 should give you 48, and that gives us 176 times 10, which is 1,760 meters cubed. So that's what you should get for the volume of this prism. Now we're going to work out the capacity. We can convert directly to capacity because meters cubed is the same as kiloliters. So that's going to be 1,760 kiloliters. Okay, so now we have the volume and we have the capacity. Now we're going to go and work out our surface area. So the surface area is 2 times the area of the base plus the perimeter of the base times the height. Okay, so the area of the base is going to be the same as what I did over here. It's 2, first, and then the area of the base is a rectangle, which is 16 times 8, plus the triangle, which is half times 16 times 6, Okay, then I'm going to add to that the perimeter of the base multiplied by the height. So the perimeter of the base, again, I'm just going to add up all the sides around that base shape. So I've got 10 plus 8 plus 16 in brackets plus 8 plus 10. You could also have said 10 times 2 plus 8 times 2 plus 16, because there are 2 10s and there are 2 8s. Okay, and then we multiply that by the distance between the two ends, which is 10. Okay, so now I've got 2 times 128 plus 48 in brackets plus 10 plus 8 plus 16 plus 8 plus 10. That all gives us 52 times 10. Okay, so 2 times 128 plus 48 is 2 times 128 plus 48 is 176, the same as it was over there. That gives us 352 plus 520, which equals 872 meters squared. So that's what you should have got for that question. And that's how we work out the volume and surface area of prisms. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.